In this section of notes, we're going to revisit the idea of type 2 error and also introduce the idea of the power of a test. So we already talked about how that the probability of a type 1 error is equal to alpha. And remember, that is when the null hypothesis was true, but we rejected it. So now for a type 2 error, that is when your alternative hypothesis was true, but you failed to reject the null. And we didn't have a probability for that just yet. And now we also have something called power. Power is how likely it is that you are to reject the null for one specific alternative value being true. So usually our alternative hypothesis has a whole bunch of values. It either has a less than sign, a greater than sign, or a not equal to sign. But power requires you to say, okay, alternatively, this is a very specific value. So maybe we're talking about the basketball player again, and maybe they're claiming to be an 80% shooter, or alternative was that they're less than an 80% shooter. You'd come up with some alternative like maybe they're really a 70% shooter. So you would need a specific alternative value in order to calculate the power. And you really don't need to be able to do a whole lot with the calculations here. What you mainly need to do is know what power and type 1 and 2 errors are, and also how to adjust them. So let's look at an example we looked at previously. So we have a potato chip company, and they want to make sure that they don't have more than 8% of their shipments having blemished potatoes. So then our null hypothesis would be that it's exactly 8%. Alternative would be that it's more than 8%. And let's say we actually had a shipment that was 11%. So we need to have some specific alternative value in order to work with power. So the picture you see in front of you, that is our distribution, our sampling distribution, considering that the null would be true. We've got the portion shaded, which is our type 1 error. So that's our alpha. And then what we're going to add on top of this is what would happen if it's really 11% blemished. So if we put this right on top of this, then what we see is the 75% that's shaded. That is now the power of your test. So if it's true that really 11% of this shipment is blemished, then we would make the correct decision to reject that shipment, to reject the null hypothesis, about 75% of the time. Again, you don't really need to be able to do any of these calculations. You need to know the relationships between type 1 and type 2 error and power. So here's a summary of what you need to know. We've got this picture that we had in an earlier section of notes where we have type 1 error, for example, being that the null is true, but that we rejected it. We've got the type 2 being where the alternative is true, but we failed to reject the null. And now we're adding power to this picture. So we have some alternative that is true, and we correctly rejected the null. We knew from a previous section of notes that the probability of making a type 1 error is alpha. The probability of making a type 2 error is beta, just another Greek letter, and it's equal to 1 minus the power. So in the potato chip problem that we looked at a minute ago, where the power was 75%, then the probability of making a type 2 error would be 25%. You need to know that the definition of power is the probability of correctly rejecting the null, given that you have some alternative value that's true. And then if we turn that into a sentence, if you're asked to interpret what the power means, so you're saying if this alternative is true, it's got to be a specific value. Like in the potato chip one, we said 11% were blemished. Then there's a 75% probability, or whatever your power is, of finding convincing evidence to reject the null. So finding convincing evidence that only 8% of the potato chips were blemished. Okay. And then this is new. This was not in our example. if you want to increase power, so increase the chances that you make the correct decision about rejecting the null if some alternative value is true. So that would be a good thing. You do want to increase power if you can. One thing you could do is you could increase your sample size. One thing you could do is you could increase your alpha size, but that's a trade-off because that's the probability you make a type 1 error. And the other thing you could do is you could increase the distance between the null and the alternative. So like in the potato chip example, our null was that it was 8%, and then our alternative was that it was 11%. If you made these further apart, like if you made this 0.15, that would put a larger distance between 0.08 and 0.15. That would increase the power of your test. So it's going to definitely be a trade-off. You need to, when you're designing an experiment or a study, decide which is worse. Is it worse to make a type 1 error, or is it worse to make a type 2 error? And that will be different for every problem. And then that will help you make some conclusions about what's a good alpha value to pick to have a good amount of power in my test, but then not make me overly likely to make a type 1 error. As usual, don't forget to try the practice problems for this section before moving on.